Alright guys, here's a video for significant figures. So this is going to be a concept that's new to a lot of us and it's going to be somewhat challenging. So I ask that you guys really kind of pay attention as we go through these, take down some of the notes, pause the video as you're writing some of the stuff down, reflect on it, try the questions, and then make sure that when you guys run into problems, you write down the questions that you guys have at home and ask me tomorrow in class. So let's take a look at this stuff for significant figures. Now, we're going to do a lot of measurements in chemistry, and we're going to talk about values being significant. And the whole idea is that, our measured values are only as precise as the tools that we're using. So in this example here, I got a couple different pictures. A graduated cylinder, a beaker, a graduated cylinder that is measured in milliliters, and also a burette, which is actually tenths of a milliliter. It's a very, very small measurement. And you can see here different values or different volumes in each one of these. So here you can read the meniscus here, and we kind of would guess that this would be 28 milliliters. And I don't want to say guess, but we would kind of read this as 28 milliliters. Now, one of the things that is tough is you can't really get this 8. The second number is always an estimate when we're doing measurements, right? I see that I have a 20, and I see that I have a 30. Well, I can tell that my meniscus is closer to 30 than it is to 20, so this 8 is actually an estimated value. Same thing's true when I'm looking at a graduated cylinder. I have 28, I have 29, I'm just slightly above this 28, so I see that this is closer to 28, so I have this 28 milliliters, which I know, but this last value of any measurement is always estimated. So in this example, just slightly above, we'd say about 0.3. Same thing true with the burette. Now I have my meniscus right here. When I'm going up here, you see I'm going up with 28 with tenths of a milliliter, so this is 28.1, 28.2, 28.3. I'm again just slightly above that, so this last value here is just estimated to be about a 2, so 28.32. So you can see that the tools that we're using, the devices that we're using, can kind of affect the measurements that we're making. But whenever we're making measurements, this last value is always estimated. Our measured values, when they're measured precisely, are called significant figures. And we're going to be working with significant figures, and it's going to be important to understand the numbers that we're working with, what values are being considered to be significant, and how they affect our results. So let's kind of understand these sig figs, and then we're going to actually look at how to count up sig figs in this video. Now, when you look at these two numbers, 400 milliliters and 400.0 milliliters, you'd say, well, what's the difference? They're the exact same. If I was going to punch them in the calculator and do any sort of mathematical equation, I have the same exact result, no matter what. And you're absolutely correct. 400 and 400.0 are exactly the same. But the difference is in how they were measured. If someone gave you this 400 milliliter measurement, well, we really only say, and this is something you're going to get into, this has one sig fig to it, right? Meaning that this is actually only measured to this value right here, because the next value is actually an estimate. So we have a whole range that this is possible in. We know that this is closer, if I was measuring this, to 400 than it is to 500, but there is this range of error that's really, really large because I only have one number that's actually been measured significantly. When I look at 400.0, not only do I have the zeros here, but I also have this decimal place here. And this decimal place is kind of giving me a value saying that I've measured this all the way down to the tenth place of the decimal. Okay, so this value here, the 400.0, is much more precise when we're looking at measurements because it's measured to a smaller degree of uncertainty. So while these values are the same mathematically, precision-wise, they're very, very different, with the 400 having a very large range of error or uncertainty with it, with a 400.0 having a very small range because this is measured with a very much more precise device. So that's kind of why we use significant figures. What we're really going to take a look at, and the new part is going to be about how to count and understand how many significant figures there are in any given number. So these first two slides that we just took a look at are just kind of an explanation of what significant figures are. Let's take a look at using numbers and actually determining how many significant figures are there. These are our 4 rules. Now what I encourage you to do right now, guys, is just pause the video and write these down. I'm not going to sit here and read through these. I'm actually going to explain these as we go through a couple examples and as you guys try a couple examples tonight with your video lesson. So take a second, pause it, write it down. So let's explain those four guidelines that we had by using some of the examples that we're going to take a look at. What we're going to do is actually determine how many significant figures are in any given value. So here we have an example. I was given this value, 3.100. My job is to figure out, well, how many of these numbers are considered to be significant? The first step, or the first guideline that we have, is looking for a decimal. We want to determine if a decimal is absent or present in the number that we're looking at. So I have 3.100. I see, yeah, there's a decimal. It's right there. So I would say that my decimal is present. Now, we're done with guide number one. Our second rule. It says start on the Atlantic Pacific side. Well, what am I talking about? Well, this is the idea. This decimal is going to be your key indicator to determine on what side of the number you're going to kind of work across from. If I have a decimal that's present, well, then I start on my Pacific Ocean side of my number, which is just the left side of my number. So Pacific is just talking about the left side of the number. So I'm actually going to start, when I'm doing this next step here, on this side of the number, the left side. So here I go, from here. I'm going to work my way across it. So that's the second step there, just kind of figuring out what side you're going to start on based on whether your decimal is present or absent. My decimal is present. I start on the Pacific side, which is my left side of the number. So now it says I'm going to work across the number to a non-zero number. Okay, well, non-zero sounds kind of goofy, but what it means is any number that is not zero. So what I want to do is actually take my little arrow here and just start on this left side and work my way across till I hit a number that's not zero. So here I go. I'm starting on the left side and I hit the first number that's there. It's a 3. Well, 3 is not 0, so that's considered to be a non-zero number. Good. We've hit the first non-zero number. We're done with rule number 4, or 3. Now that I've hit a non-zero number, I can actually count how many of these values are significant. So the first number that I hit as non-zero is a 3. This number that I hit that's not zero is considered to be significant, so this is significant. This number and every number after that is also significant, so this 3 is significant, the 1 is significant, and then both of these zeros are actually measured values that we consider to be significant. So when looking at this example, 3.100, I would say that this has 4 significant figures. I'm just going to write sig figs because that's what we're going to call them and abbreviate them. So this one has 4 sig figs. The decimal is present. I started on the Pacific side, moved across my first non-zero number. That 3 was significant, and every number after that is also significant. 4 sig figs for this first example. Let's kind of keep working through this and see another example, and we'll have you guys try some out, and obviously we'll have you guys try some tomorrow in class as well. So I got 7,900 for this second example. My first job, like it was before, is determine whether there is a decimal. I don't see a decimal in this one, so I'm going to say that my decimal is absent. Rule number 1, done. Because my decimal is absent, I start on the Atlantic. Atlantic and absent start with the same letter, the A. So I'm starting on this side of my number, which is the right side of my number. So I'm going to start on the right side of my number when I go move across it or work across it. Cool. So now I'm going to actually work across my number. I know that I'm starting on the right side, the Atlantic side, and I'm going to work across this, like it says here, to the first non-zero number. So here I go. I'm starting on the right side. I'm going to work across this to the first non-zero number. The first thing that I hit is a 0. That's 0. I have to keep going. The next number that I hit is a 0. I got to keep going because that's a 0. It doesn't count. The next number that I hit is a 9. This 9 is my first non-zero number. It's the first number that's not 0. So this is the first number that we consider to be actually significant. It's the first number that's been measured out to be significant. So once I hit that first non-zero number, that number is considered to be significant, and every number after that is significant. So let's count up our sig figs. Well, this 9 is considered to be significant, and this 7 is also considered to be significant. So in this example, with 7,900, only 2 of these values are considered to be, or two of these numbers, I should say, are considered to be significant or measured out to precision. So we have 2 sig figs in this second example there. Let's take a look at one more example and let you guys try some on your own. So in this example, I have 0.00740. My first job, determine if my decimal is absent or present. Well, I see a decimal right there. My decimal is present. Rule number 1, done. My second rule, well, if I'm on the present if I have a present decimal, I'm going to start on the Pacific side. So I'm going to be starting on the Pacific side of my number, which is the left side of my number. Rule number 2, done. Now I'm actually going to take my little arrow and work across this number from the left side towards the right until I've hit the first non-zero number. First number that I hit is 0, I got to keep going. Second number, 0, keep going. Third number, 0, got to keep going till I hit that first non-zero number, and that first non-zero number is 7. So that first non-zero number being 7 is the first one that I consider to be significant. Now here's the tricky part. Once I hit the 7, this 7 is significant, and everything after this, everything to the right of this number is also going to be considered to be significant. It's all measured values. So we've actually measured this all the way down to this 0 right here. So the 7 is significant, the 4 is significant, and this 0 is also significant. So the first number that I hit that's not 0 is significant in every number after this. So this value has 3 sig figs to it. Get familiar with these 4 rules that we used here. Get familiar with the geography if you're not that good, the Pacific being the left side and the Atlantic being the right side, and start applying them and trying some problems out here tonight for your work. If you struggle with them, it's okay. This is new to a lot of us. Just make sure you ask the questions tomorrow in class so you're ready for this test that's coming up. Good luck.